Hi everyone, are you able to hear me and see my screen clearly? All right, so hi everyone, I'm Sandeep Giri and great to have audience today. Give me a second, I'm just trying to fix a couple of things. All right, welcome everyone to the first session of Big Data with Spark and Hadoop. And today we will today is the first session of our course on Spark. But since um, But since Spark actually runs on Hadoop and it is dependent on it can be run efficiently on Hadoop. So we will basically cover both in this session. Rest of the course will be only Spark. Okay. And yes, slides and videos will be shared with everyone. Great. All right. So great to have all of you in the session. And we have people from many countries today in the session. We have people from Berlin, we have people from Denmark, we have people from Toronto and Singapore and Tokyo as well. Indonesia, India, and Tokyo. All right, great to have all of you in the session. All right, and these sessions are very interactive, so please ask questions using Q&A window. Periodically, I'll take a break from the presentation and will try to answer your question. Now, so welcome to the first session of Big Data with Spark. It's a first session and it's going to be 3 hours long. And, and so to enjoy the session, please participate in the chat and participate in the question. I can read your questions and I can read your chat, but I may not be able to answer your questions in chat right away. And so this session is going to be 3 hours, and trust me, these 3 hours, it's going to be really short, and I assure you that you'll not feel sleepy. All right. So the agenda for today's session is, in the first half, we will talk about the introduction to big data, and then we'll take a short break of 10 minutes. And afterwards, we will talk about the architecture of Spark and Hadoop. All right. So please introduce yourself using the chat window while others are joining. And session is being recorded, and recording along with presentation will be shared with all of you. So do not worry. And in case you want to take a screenshot of something, feel free to do so. All right. And we do not restrict you from taking a screenshot or anything, because we anyway will be giving you the recording along with presentations. All right. So this is the session 1 out of 18 sessions on big data with Hadoop and Spark specialization. And it's basically the first session for the Spark course that's starting today, while the Hadoop course, Hadoop and Spark course is midway. So we have finished the Hadoop part already, and then now we are starting with Spark. This session in itself suffices as introduction to big data technology stack. And everyone except me is muted. So please ask your questions using Q&A window. And if you have to say something, you can raise your hand or you can use the chat window. So there are three ways to interact. One is using the chat window, other is using the Q&A, and third one is using by raising your hand. Okay, so and I'll try to read the questions before answering anything. So to help me give a better answer, please keep your messages or questions short, but avoid chat language. All right, great. So about a brief about Cloudxlab. Some of you are already aware about Cloudxlab. We are trying to make learning fun and for life. Earlier, our domain name was No Big Data, but since we moved into bigger technology stack, we have renamed ourselves to Cloudxlab because all of our learning is around cloud-based lab. All right. So, so one common thing that we are trying to do at Cloudxlab is we are trying to make learning fun and for life. And how are we doing that? By doing the live streaming, by doing the videos, and by providing very engaging quizzes along with hands-ons. Hands-on is something that is unique about us. I'll talk about it briefly. We as part of the courses, we provide projects and we provide case studies, and all of this is based on real life use cases. All right. There's a feature called Live on YouTube. Let me just give it a shot. And looks like we can do a live video. All right. Let me just give it a shot. All right. I hope this works. All right, just give me a second. I'm trying to stream the video live. Okay, looks like. All right, so let me give it a shot again. All right, so that there are many people who are. So it says that enable live stream is not there yet. Okay, let me give it a shot again. It doesn't seem to allow me. We'll try it later again. Maybe we'll do that later. And yes. Okay, never mind. So we'll try that a while later. Okay, maybe in the next session. All right, so all right, so all right, so about Cloudxlab, we are trying to make learning fun and for life. All right, so the automated hands-on assessments is something unique about us. The idea is that you learn by doing, and for doing so, what we have done is we are the pioneers of the Cloudxlab. Basically, we have pioneered the idea of the lab on the cloud. And as of now, quite a few companies are trying to do the similar thing, but we were kind of pioneers in the big database lab. All right. So the way automated hands-on assessment works is that there is a problem statement, and using the cloud-based lab that we provide, you have to do the hands-on assessment, and then it automatically checks whether you have done it correctly or not. So here is one example. This is the first example where the lab is asking you, as part of assessment, it's asking you to log in. And once you log in successfully, you come over here and click on I am done. And once you click this, it'll go and check whether you have done it correctly or not. This way you get immediate feedback about your work. And this helps you stay engaged, and this helps you stay on the track. It is like instructor trying to help you all the time and trying to check whether you have done things correctly or not. Okay, so hands-on assessment is something that is unique about us. And the other set of hands-on assessment which we have built is based on Jupyter, whereby on the left-hand side you are given a question, and on the right-hand side you have to solve that inside Jupyter. Jupyter is a web-based interface to interact with many interactive programming languages such as Python, Scala, and you can also interact with MySQL and so on. So we are able to make all kinds of assessment based on Jupyter. So we not only provide cloud-based lab, but we also provide a hosted Jupyter for you, so that you don't have to install anything at all. And on top of it, we provide you these questions and problem statement, and then it automatically checks whether you have done it correctly or not. So here, once we have done it correctly, and when we click on I'm done, it says good job because we have done it already. Okay. All right. So a question from Kante says that is this an audio conference? No, it is basically only the instructor is speaking and others are muted. You can ask your questions using Q&A window. All right. So a question from Satish is that I missed Hadoop webinar. Don't worry, this is the Hadoop webinar. We are just getting started. All right. Any recordings available? Yes, these will be made available to you after the session. Great. Great to have questions. Now, a question from Neil is, how do we open the lab? You can go to the Cloudxlab. If you've already taken the course or taken the lab subscription, you will be able to see my lab section, as well as in certain assessments, you will see the lab enabled on the right-hand side. All right. Great. Great. So about the instructor, I am Sandeep Giri, and I'll be the instructor for this course. I graduated from an institute called IIT Roorkee, and I have worked largely on the large scale computing. I worked at DE Shaw. At DE Shaw in 2002, we had 10,000 node cluster, and we did large scale computing when nobody was around. Nobody, as in there was no company such as Google or Amazon or Facebook at that point of time. So we take pride in saying that we had done the distributed computing long back. So essentially, we were doing big data at that point of time. And then I joined InMobi. In between InMobi and DE Shaw, I founded a document management company, and at InMobi, I worked on large-scale machine learning problem, such as recommendation generation on 200 terabyte data. 200 terabyte data was my first encounter at InMobi, and that's where we worked on Hadoop, and we worked on the entire stack at that point of time. Afterwards, I joined Amazon and built large-scale computing frameworks at Amazon for Amazon detail page. So this is about me. I am a software engineer at heart, and I enjoy explaining technologies to friends and anybody who wants to learn something. And that's the reason why I started knowbigdata.com and now cloudxlab.com. All right. So the sole idea is to help people learn various technologies. All right. So the course objective is learn to process big data with Spark and Hadoop. All right. So in today's session, we will cover basics of big data, and then we will talk about Hadoop and Spark stack. Hadoop stack is only introduced now, and afterwards we will, from session 2 onwards, we will focus a lot on first learning Scala, then we will learn Spark, and we learn how to process humongous data using Spark from session 3 onwards. All right, great. So before we get started, before we get started, let me clarify some of the terms. These terms are used very frequently in the industry, so I would like to you- define these terms before we start using these terms. The first term is data variety. You must have heard about structured data, unstructured data, and semi-structured data. So let me try to explain this. So data is largely classified as structured and unstructured. And somewhere midway, we have semi-structured. Somewhere midway, we have semi-structured. What does it mean? The structured data means we have a clear picture of what are the columns in our data, what are the rows in our data. That is structured data. So a well-formatted Excel sheet, Microsoft Excel sheet, is an example of structured data because we clearly know the fields and we also clearly know their data type. Um, a table in the database, say MySQL, Oracle, Postgres, or Microsoft SQL, or any other kind of database, the table is well-defined structured data. Why? We have clear picture of what are the fields, and we have clear picture of what are the data type of each fields. Okay, so that is structured data when we have clarity on fields and their data types. The examples are data in database. All right. So what does it mean by a field? Field could be like columns in your Excel sheet or columns in your database table. All right. Now, on the other extreme, we have unstructured data, data in the form of plain text file, binary files such as videos or music. That doesn't have a tabular structure. So we do not know the fields, we do not know their data types. That is unstructured data. If you have a plain text file containing the stories of something, that is unstructured data. It doesn't have a tabular structure. Okay, so unstructured data, we neither know what are the fields, and and hence we also do not know their data types. This is unstructured data. And somewhere midway, we have semi-structured data. What does it mean by semi-structured data? Semi-structured data, we know what are the fields, but we do not know their exact data types. Okay, so semi-structured data looks more like a tabular structure, but not always. Okay, some of the fields might be missing, some of the cells might be missing values, and so on. So semi-structured data looks like a tabular structure, but we do not know the data type of each field. Okay, so in semi-structured data, we have clarity on what are the fields, but we do not have the clarity on their data types. This is generally called semi-structured data. And the examples of semi-structured data is the data in the form of, say, XML. In XML, we know the fields sometimes, but to infer the data type of XML, the fields in XML, we require extra information. Similarly, the data in in JSON, we do not generally know that which one is the data type of what, and hence the JSON is also classified sometimes as semi-structured data. All right. Now, to translate unstructured data could be in the form of videos and audios, and it could be in the form of the something which we right now do not know. All right. So unstructured data could be anything which does not have fields in it. All right. There are many file types that we use. Those are the examples of the many file types which do not have the tabular structure, which does not have the definition of fields, are called unstructured data. All right. For example, even the HTML files or even the raw data of videos and audios or map files are generally considered unstructured. All right. Question from Gopinath is that why is audio treated as unstructured data, as we know data type as MP3? So we know the format of the entire file, but we do not have the column format. We do not have the columns in the data, but we can convert MP3 file into tabular structure, right? By extracting the header information of an MP3 file and converting into tabular structure. If you have many MP3 files, we could convert that whole information into tabular, and that is known as, this translation is known as ETL. So we can convert the unstructured data into structured data by processing this, by applying certain rules, by programmatically, or by using third-party tools. We can convert the unstructured data into structured data. And this process is known as extract, transform, and load. ETL. ETL is generally used to transform data from one format to another and convert raw data into something meaningful. All right, great. So all right, there are a few questions. Let me just go over these questions. A question from Kantesh: field is akin to a column in a table. Thank you, Kantesh. All right. A question from Shailesh: can you give some example of what type of analysis can be done on unstructured data? How can we interpret in our processing? We'll cover it at a later point of time. Do not worry about this. Okay. A question from Minmay: what about file formats like CSV, Paraquet, and Avro? Quickly, we'll talk about Paraquet and Avro at later point of time in the course. But right now, let me just quickly clarify. See, in CSV file, we know the fields, but we do not know the data type of fields. Okay. We do not know the data type of fields because in CSV file, all we have is comma separative values, right? And therefore, CSV file is generally called a semi-structured data. A question from Minta: is data from sensor or camera unstructured one, a structured one, or semi-structured one? So it would depend on the format in which the sensor is providing us the information. But mostly, when the data comes from a sensor or camera, it's generally in the form of either semi-structured or unstructured format. A question from Noah: what are the advantages of MySQL library over MySQL? I think we can take it offline, maybe over the discussion forum. I would love to answer this question, but not in the current context. All right. You could come over to our discussion forum, go to Cloudxlab, click on the discussions, and you will be able to ask questions there. All right. A question from Archana: are log files structured or semi-structured? Log files are unstructured data. Great, great. So this was the definition of structured and unstructured. But trust me, when you start When you start processing data, you will yourself figure out what to do in case of unstructured, what to do in case of structured and semi-structured. And that's the objective of the course. We would learn to process all kinds of data, and that too humongous data, as part of this course. All right. So I'm hoping that you will be able to see the Q&A window. Uh, all right. So please ask the questions using Q&A window. All right. Now the next term that we talk about is distributed systems. What does it mean by distributed systems? Distributed systems are group of networked computers, the groups of network computers that interact with each other to achieve a common goal. To achieve a common goal. What does it mean? It means that we wanted to solve a problem, so we connected many computers together, and then we are utilizing all those computers in order to achieve a common goal. In order to achieve a common goal, right? Though we network the computers in a computer center, but since we are not achieving a single we are not achieving the solution to a single problem using the computers in a computer center. That mean and therefore we do not call that as distributed computing. So computers connected in computer centers are not necessarily distributed computing unless you are using those to solve a single common problem. Now, a quick question to all of you: how many bytes are there in a petabyte? First question, just to check if you are awake. Kantesh, that is 1 megabyte. You can use chat to answer the questions. Windows says 10 to the power 15. All right. Wonderful, wonderful to get your answers. Great. So most of you have been able to answer it well. Now, so the answer is close to 10 to the power 15. Right? And basically the way you remember is in terms of in this way. One megabyte means 1 kilobyte means 1024 bytes, and 1 megabyte means 1024 kilobytes, and 1 gigabyte means 1024 megabytes, and 1 terabyte means 1024 gigabytes, and 1 petabyte means 1024 terabyte. All right, so you can say kilo, mega, giga, tera, peta. All right, so and as we use the term, you'll get to know this. Great. Great set of answers. So now question is, another trivia is that how much data approximately do you think Facebook stores in one day? All right. So as per their last information, they were storing 600 terabyte. Looks like they have increased that amount of data now. And maybe Sankar is right that it might be storing close to 7 petabyte. Right? So basically in one day, Facebook is storing close to 600 or maybe 1 petabyte or 2 petabyte data per day. Now, Now, by the way, you'll be surprised to know that the terabyte is actually a pretty huge data. Okay, terabyte is actually a pretty huge data, and you will see that as we proceed further, that to process a terabyte data, it takes a long time. So petabyte is definitely a big data. All right. Good. Now let's talk about big data. Now, a question to all of you again, the third question. What do you think is big data to you? What does it mean by big data to you? All right. Use the chat window to answer the question. If you have a question for me, then use the Q&A window, please. Good, good, good. So most of you are right. Most of you are right. So in very simple words, so why we want to define big data before moving ahead in the course is we would like to be on the same page when it comes to definition. Okay. Now, the in very simple words, big data means the data of very big size, the data of huge size. Okay. And how huge? That you cannot process using usual tools. And what does it mean by usual tools? Usual tools means something like a database or your file system, the existing tools using a single machine. So big data is simply data of very big size that you cannot handle or process using usual tools such as your usual file system, usual database, and so on. And what kind of unusual tool do we need is the unusual tool we need is distributed computing, distributed architecture, meaning we would require many computers to solve such problems. And when we say solve such problem, it means solving in expected time, in reasonable amount of time, which is okay with us. So in very simple words, the data of very big size, huge data that we can't handle or process using our existing traditional tools, such as a file system and a usual database. And we require this new genre of tools which are distributed. Which basically, in simple words, big data is all about distributed computing. Big data is all about utilizing many computers to solve the problem. And hence, in this whole course on big data, everything that we do would be related to distributed computing. Everything that we do in this course will be related to distributed computing. So the data could be any form. It could be of structured or unstructured format. Okay. So irrespective of the format of the data, if for our need, we need it for our need, if we need many computers instead of only one to get the output in reasonable amount of time, then we call that big data. Big data means the problem's so big that you cannot solve using one computer, and hence you need distributed computing. So big data, when we call it big data, though big data is kind of industry, but big data, the way we are going to use is big as adjective, and data means the information or the bytes. Okay, so we're going to think of big data as huge data. That's all. Okay, so huge that you need a distributed computing. architecture. All right. Great. So this is our definition of big data. If a question from anonymous attendee is, if all my data is structured and the size is big and our current process in data housing is not an issue, do we require big data architecture? Okay. Question is, do we require big data architecture if we are fine? Okay, the answer is that if you are going to grow this data, if you have a need of, you know that in like 2 years of time, it is going to be impossible to use our existing infrastructure, then definitely. Also, if your current data warehouse is doing great, and you do not foresee any growth in data patterns which will lead you to distributed architecture, if you do not see that kind of data growth plan, then right now you don't have to worry about big data. All right. Yes, thank you, Salis. In this scenario, time will be considered to make the decision. All right, so this is our definition of big data. Now, this is the traditional definition of big data, and this is something that we kind of remember, all of us kind of remember. And we're going to look at this definition. Big data, characteristics of data are three. First one is volume, meaning how much do we need to store? Second, velocity, meaning how fast do we need to transfer and to how many people? Variety, in what format is our data and what kind of translation do we require and what kind of processing we require? Variety, here we'll be using variety in two forms. One is the complex structure of data as well as the complex program, the, the, the complexity of nature of our program. That will be part of variety. So the characteristics of data are volume, meaning how much do we need to store the data at rest. When we have, let's say we want to store really humongous data, and we can either use our normal file system or we could use HDFS. Okay, we'll talk about that later. So basically, when you have humongous data to store, your existing file systems may not suffice. For example, if you think about Facebook, they're storing 300 petabyte of data in now say 300 days, and every day they are close to storing around half petabyte data, right? So this is humongous data. You cannot really use your normal file system. Even if you use your normal file system, you'll need to manage all of this juggling between many more machines. So you inevitably will be using many more machines. Facebook cannot store 300 petabyte data on a single machine in any way. Therefore, they need distributed computing. They need many computers to store such a humongous data. All right. So volume is one characteristic of the data. If the volume starts growing, then it might push us to use the distributed computing, and hence our data might be or would become the big data. So, or in other words, if our data is big data, we will not be able to store it on a single computer, and we will require a distributed system to store such a huge data. The second characteristic is velocity. Velocity means how fast do we need to move the data in motion. Problem involving handling of data coming at fast rate. For example, number of requests that are received by Facebook and number of uh, YouTube streams being sent to the users. If you see that the data, humongous data is being sent at a very fast pace to the end users. Similarly, Google Analytics is receiving, because Google Analytics gets embedded into everybody's website because people want to analyze the traffic on their website. So they embed Google Analytics URL, and that way Google is able to give you a good analytics about your users. But Google Analytics as a product is receiving the request from almost every website on the planet, right? Everybody who is embedding Google Analytics on their website. So these are the examples of velocity. When the velocity becomes really high, mean either too many requests or we need to transfer too huge data in too less time, then we can't really use one single system. We would require a distributed system to provide high velocity. And this is called data in motion. The third characteristic of data is variety. Variety means data in many forms. Problems involving complex data structures such as graphs, maps, and problems involving churning these complex structures is categorized as variety related problems. So either we have a problem of processing the data, storing the data, or transporting the data, right? And when and any of these characteristic of the data, if it pushes you to use many computers instead of one, then we call that our problem is big data problems. So characteristic of big data is that either of these three will become the bottleneck. Either of these three, volume, velocity, and variety, will become your bottleneck. All right. Let me further detail the variety part. Let's say you have to go from one place to another and you are given the map. Even though map is not really big data, a map of a country is hardly couple of gigabytes. But to find the path from one point to another using map is a hard thing. You need to enumerate over all possible paths from one point to another, and hence it's going to take a long time. And therefore, a problem of finding path in a huge map, finding the shortest path in a huge map becomes a big data problem. Not because data was too huge to store on a single disk, but because the computing involved was really heavy. Therefore, problems related to variety can also push you to use the big data or distributed platforms. Okay, so the course is actually about the distributed computing. Okay, the course that we're going through is basically the course on distributed computing. All right, so now let me, before jumping to the question, let me try to answer a question. Question from Anil is, there are other terms like veracity and value and so on. So I'll not get into those terms because they look like too much of marketing terms to me, and therefore let's stay away from that. We will just focus on learning the distributed computing. All right. Because there's a veracity, which means the data you do not know anything about and blah, blah, blah. So we'll just keep away from that right now. Our question is, how can we create sample program in big data with unstructured data without distributed system? I mean, my laptop. Yes, a good question, Naveen. Question is that if I have to learn big data, then how can I create a simple system? The truth is that you can create that using downloading these virtual machine kind of setups of Hadoop and Spark, but you're not really doing big data kind of setup. For that, you would require many machines, and that's the reason why we created Cloudxlab. Cloud-based lab was created basically for the same thing. We realized that to learn distributed computing, you should have distributed computing, right? Therefore, we created a cluster for all our students, and they all started using it, and hence it became quite useful to the people who are trying to learn big data or distributed computing. Okay, good question. Let me move on. Now, a question to all of you. Question is, time taken to read 1 TB from hard disk. How much is it? We are talking about 1 TB data. And when we say read, it means reading the data from end to end. We're not saying 1 GB data. And we are not saying that you need to read the entire data into the memory. We are just saying that access the data and forget it. Great set of answers. So approximately somewhere between 4 to 6 hours, or sometimes it might take 4 to 10 hours, based on the hardware that you're using. Okay, based on the hardware that we're using. So time taken to read the data from 1 TB, time taken to read 1 TB from hard disk is dependent on what kind of hard disk we are using, whether we are using solid state hard disk or using hard disk drive. Okay, if you so if had I said that how much time it takes to read 1 TB from disk, then your next question would have been that what kind of disk is it? Is it solid state drive or is it the hard disk drive? So here we're talking about hard disk drive, and even if even if you have really fast hard disk drive, it is going to be close to 4 hours. Okay, and all right. So what we see here is the time taken to read 1 TB from hard disk is close to 6 hours, and no matter no matter what is the processor of your computer, this time is irrelevant. This time does not depend on the memory of your computer or the CPU, the processor of your computer. It is dependent on what kind of disk are you using, how fast is your disk. All right, so when we talk about big data, generally this hard disk drive is the culprit. Generally this is the one which is causing the bottleneck. And if we are using SSD, the time is going to be at least um, at least 10 times faster than this. Okay. All right. So here in the question, we are saying the read in not we are not reading into the memory. We are just reading and forgetting. We're just scanning through the data. All right. Great set of questions. So it generally takes close to minimum 4 hours. It might take up to 10 hours. All right. The idea that I'm trying to reach to is that it takes a long time to read data from the disk, and processor doesn't help. Processor doesn't help because of the disk. All right. Other thing is somebody asked about solid state drive. So solid state drive, even though it's faster than normal hard disk drive, it actually is extremely costly, and there is no 1 terabyte disk available in SSD. Okay. A question from Nawal. The only the hard disk drive requires a lot of time for reading, writing. Mostly, if the data is bigger, the hard disk drive after a few gigabyte of data, it becomes really a bottleneck for both reading and writing. Writing is further slower. Okay. Now, a question to all of you: how much time is taken to read 1 terabyte from? Sorry. Now, let me ask you another question now. After the first question, question is, if you have to count just vowels in 1 petabyte data every day, if you have to count just vowels in 1 petabyte data every day, do you need distributed system? Okay. Imagine that every day all you're doing is counting, going through the characters and just counting the how many vowels are there. Okay, so do you need distributed system? So question is, if let's say you have 1 petabyte of data and you want to read it from the disk, it is going to take how much time? 1 terabyte took 6 hours. 1 petabyte is going to take 6,000 hours minimum. Okay, 6,000 hours minimum. And so question is, do we need distributed system? Do we need multiple systems, or can we get it done on one computer? Yes. So 1 petabyte is really huge amount of data. We would need distributed system. Okay, we would need distributed system. So you can answer. You can answer using chat window instead of questions. That makes the life easier for me. Okay. All right. Good. So we cannot really count the vowels even in 1 petabyte data using a non-distributed system using a single computer. What does it prove? It proves that no matter which processor are we using, no matter what kind of um, configuration are we using, we cannot achieve such kind of problem using one computer. We will require many hard disks. Many hard disks would require many computers, and hence we would require a distributed system just to count vowels in 1 petabyte data every day. The problem is extremely simple. Problem of counting vowels is extremely simple. It does not require too much of CPU. It does not require too much of RAM. We'll talk about these 3-4 terms again, and still we require many computers. So it proves that until there is a miracle that happens in case of storage, to process data, we would require distributed computing if the data is big. All right. So here's the standard chart which shows how the data has grown. On one hand, we have analog store. On another, we have digital storage. Analog storage is in the form of physical books, while digital storage is in the form of digital data, in the form of CDs, DVDs, and so on, right? So the data in the form of digital storage has been growing really at a very fast pace, has been growing at a very fast pace. And as you can see that 2002 was a time when suddenly the digital age started. because the data started growing exponentially. The digital data started growing exponentially while the analog data kind of started shrinking. So you can see that the digital storage grew exponentially after 2002. And my question is, why so? Why it happened that way? The answer is multifold. The answer is devices and connectivity. So, so the heart of the problem of data is being able to generate that amount of data. So being able to generate amount of data in 2002, as the data started growing more and more. Why? Because the devices became available and connectivity became available. Wi-Fi connectivity, 4G, NFC, GPS, and so on. That kind of connectivity was available. Along with that, we got devices. Devices means we got all kinds of devices, phones and sensors and so on. On one hand, the devices became cheaper, faster, and smaller. On the other hand, connectivity became faster and cheaper. And if you multiply the two factors, devices and connectivity, you will get that the amount of data generated is huge. And to put devices and connectivity to use, various kinds of applications came into play. The social network and the Internet of Things and so on. There are many applications such as Facebook, YouTube, Google+, Twitter, Flickr, Yahoo, and so on. All of these came into play at that point of time. Gmail, and basically the basically since the devices as well as the connectivity became omnipresent, it was possible to have many applications, and these applications started generating and creating data. And that's the reason why the digital data started exploding exponentially since 2002. All right. So this is a very important part to understand, that the phone that we carry in our pockets are actually better than the supercomputers of this time. This time, what we call supercomputers is actually were actually slower than our phone. Okay. Okay, so I hope that answers your question, Binta. A question from Sailesh: when we are on the era of growing big data every second, are the world looking for solution for duplication of data? Yes. So people are, a lot of us are trying to deduplicate data, and that's anyway happening in the silos. All right, great. Now, now the few terms that I have been using since the beginning, here are the answers to those. So when we say computer, what does it mean to us? What does it mean by computer to us? The four components are largely the big components. The first one is the CPU. What is CPU? CPU is called processor also, and sometimes it is also called microcontroller. So it's a central processing unit. What it does is it reads the instruction and executes an instruction, okay, based on the conditions. So CPU is the one which makes everything alive. Okay, CPU is the one which reads instructions in from the storage and then execute them. CPU is the one which puts everything into the motion. Okay, so CPU is the central processing unit, and the number of instructions it can execute per second is the ability of CPU. Okay, but in case of disk, reading from disk, CPU can't do much because the bottleneck is elsewhere. So CPU, the speed of CPU has been growing, has been doubling every 6 months. Okay, has been doubling every 6 months. For example, the the mobile phone which I had in the beginning in 2003, I had this smartphone, and it has touch screen and everything from Motorola. The processor of that one was 200 megahertz. Right now, I use a phone, Android phone, which has a processor of 6 gigahertz or so. All right. So the CPU speed has been doubling every 6 months. So the second part is RAM. What is RAM? RAM is random access memory. Instead of sequentially reading data from the disk, we can read data randomly from the RAM. The RAM is the place where CPU keeps data temporarily, or it loads data into the RAM so that it can process the data at really fast pace. So, and whenever needed, back and forth. So CPU, while doing its job, utilizes RAM. But keep in mind that when the computer shuts down, the RAM becomes empty. The RAM becomes empty. And when you restart a computer, everything that was there in the RAM disappears. Now, the third part is disk drive. In case of phone, this is our SD card. Okay. In case of phones, this is our SD card. So the this is the permanent storage. This is the permanent storage, and CPU basically keeps on reading data from disk drive and keep on putting it into RAM and so on based on our program. So disk drives, the characteristic of RAM was two: speed and size. How big is the RAM and what is the size? And generally, the RAMs are smaller in the size, while hard disks are bigger in the size. RAM is of the at most I've seen a RAM of 200 gigabyte, and on a normal computer it is from 4 GB to 8 GB or to 16 GB or maybe 32 GB. Okay, and in the server grade hardware, you can see the RAM to be maybe 100 gigabyte or 200 gigabyte. Now, disk drives, there are hard disk or solid state disk drives. So hard disks are huge in size and cheaper, while solid state drives are faster but smaller and costlier. Okay. The fourth component that get ignored as part of the computer is network. Since today, almost every program that we use interacts with network. So network is considered as one of the components. Okay, so if our data is really huge, we can't store if our data is really huge, we can't generally keep the entire data into the RAM. We will put it into the disk. And if it is really huge, we can't store in the one disk. We might store over the network to another computer. All right. So when the big data comes into play, at least one of these components would become the bottleneck. At least one of the components will become the bottleneck, meaning you can't go further without using some other computer together. Okay, so it could be CPU. If you are trying to do problems related to variety or complexity, such as finding path in the map, it could be the CPU that could be the bottleneck, or it could be the RAM that is a bottleneck, because you could not fit so much of data into the memory, and therefore we could not process. Okay, and it could be big. In some cases, like the problem related to the volume, hard disk is generally the bottleneck, or network is generally the bottleneck. So using these distributed frameworks, these are the bottlenecks that we learn to handle, learn to resolve using the distributed computing. For example, using Hadoop's distributed file system, we will learn how to use many hard disks. Okay, many of these hard disks in the network. We will also, as part of the, say, computing engine such as Spark, we will learn that how can we run our our logic nearer to the data without transporting the data. We will learn how not to transport the data over the network. Instead, run our programs nearer to the data. Okay, so we will learn how to how to distribute our processing onto multiple computers so that the bottleneck caused by any of these four components becomes we can resolve the bottleneck caused by any of these components. All right, now a question to all of you, that which of the components impact the speed of computing? That's right, all of the above. All of the above, as in G. A general tendency is to think that the speed of computing is only impacted by CPU. That has been sold to us by companies who build CPU, that the computer is all about CPU. No, you will be amazed to know that in case of, let's say, a website like Wikipedia, you know what became bottleneck first? It became the memory size was the first bottleneck. Okay, and in case of the problems that I was resolving at say in Mobi, it was never the CPU, it was the disk speed and disk size. Okay, because 200 terabyte data cannot be processed using a single machine. All right, so all of the above impact the speed of computing. All of the above, not only the CPU. Great. A question from Noor. Question is, but if we're just doing a plain computing example, brute forcing, then other components won't be involved. Very good point. So very good point. Let's say, so question from Noor is, let's say we are trying to do something like, say we are trying to crack passwords. Okay, I'm just taking an extreme case. We're just trying to do let's say Bitcoin mining or crack passwords. So in that case, we do not need to use too much of memory. We do not need to use too much of disk. All we use the CPU. And in those cases, yes, CPU is the bottleneck. Okay. In the problems involving variety, the CPU is the bottleneck. Okay, Saurav's question is, the disk speed is also the bottleneck in case of Bitcoin. Is that your point, Saurav? A question from Mintao is, what does coaching mean in the speed of computing? Coaching, I think you are referring to caching, probably. Is that what you're referring to? So caching means that bringing data from the disk into the RAM is called caching. Okay, keep it ready in the RAM so that when processor needs it, it is there instead of reading it from the disk again. Great. All right. Now the next question is, why bother? We agree that there is big data and there is so much of problem associated with big data. Why bother? What does it, how does it help to handle such a huge data? What are the use cases of humongous data, right? One of such use case is recommendation generation. So here what you see is the Amazon detail page. This is the page we owned at Amazon. And what you see is here it's giving a suggestion that people who bought this also bought these, right? And then there is another suggestion saying, wear it with these, right? And then if you go to Netflix, it'll say that, congratulations, movies we think you will love. Movies we think you will love. And these are the movie suggestions. So what's happening here? It's giving you, it's giving you the recommendations. And these recommendations are not hand curated. These recommendations are not there based on somebody thought that he will sell things to you, only these things, right? These recommendations are based on the past behavior of people, including yours. So for example, at Amazon, we figured out that a lot of customer purchase actually happen if we give them proper recommendations, either in email or on the website. Wherever we give, the better recommendation we give, the better trust we gain from the user, and the better are the sales. So we saw clear numbers when it comes to recommendations. We had a very clear numbers about the fact that recommendation helps people discovering products, and recommendation help people buying help people make better buying choices. So that way, in overall, the recommendations, the more the data is there for recommendations, the better it is. A question from Salis on this context. Question is there any difference between recommended content and predicted content based on user activity? It's basically both the same thing. And both of them, there is a technical term for recommendation. We call it collaborative filtering, and that's what it is. Okay. Question from Huey. Can we say that big data is distributed computing plus data mining? I would say that big data is distributed computing. Data mining is maybe a part of machine learning as of today. All right. Now, how does it happen? How do we generate such kind of recommendations? There are existing algorithms such as Mahout and now MLlib. What we do is we first create a huge table having only 3 columns: user ID, movie ID, and ratings. I'm taking very simplistic case. Okay, I'm taking extremely simple case, so be with me. So how to generate such kind of wonderful recommendations? And we will do an exercise on this where we will take the historical ratings of various movies, and then we will generate the movie recommendations for ourselves by providing our own ratings. Now, question is, okay, so question is, how to generate the movie recommendation or any kind of recommendations for that matter. For recommendations, what do we need is the information about who liked what movie. And once we have that information, what the algorithms do is they bring together those users which are similar to each other and then start giving recommendations of the movies to each other. Okay, so for example, here what we have is user ID, movie ID, and rating. So we have 3-column data. First one is the name of the user, even though technically it is going to be a number. So here, who liked which movie, how much? Who liked which movie, how much? And in this, what you see is, say, Kumar liked Matrix, and Kumar liked Ice Age, Giri liked Apocalypse Now, and Giri liked Ice Age. So you can see that out of 3 total movies, 1 movie is common between Kumar and Giri. So Kumar and Giri are 1/3 similar, right? And then if there is no other similar user to Giri, it will start recommending movie of each other to movie of one to another. Say, for example, here it is suggesting that Giri might like Matrix and Kumar might like Apocalypse Now. So this is extremely simple example of how movie recommendations are done. It's exactly the way we did in childhood, that that we would try to figure out who are the people who have similar choices like ours, and then start recommending to each other. All right, because you like that movie, therefore you will also like that. Those are another forms of recommendations. All right, so be it movies, be it products on e-commerce website, be it content on your website, be it content on your blog, or be it the be it the recommendations provided by Uber, or the provided by, say, Airbnb. All of those recommendations are done in a similar form. All right, so this is how the recommendation is done. We will run through a whole case, as in a hands-on example of MLlib during the course. All right, the second one is the e-commerce. Okay, in e-commerce, so what we just discussed was the recommendations is a very big use case of big data. Why? Because bigger the data, better will be the recommendations. If you have smaller set of data, the chance of data being skewed or chance of data being biased will be too high. Therefore, bigger the data, better is the recommendation. Then we have, in e-commerce, we have A/B testing. Okay, in e-commerce, the analysis of the user behavior is not done based on gut instinct. The analysis, even if we are trying to build a feature on our website, we do not go with gut instinct of the designer. Instead, we go with A/B testing. So for example, let's say we had to choose whether to go for red color or green color. Okay, green color or red color, we will figure this out using A/B testing. What is A/B testing? A/B testing is A versus B. Okay, that is A/B testing, meaning the term A/B testing comes from drug discovery. So when somebody discovered a drug, the testing of the drug would happen in the form of A/B testing. We will give drug to one person. The doctors, while testing the drugs, they will give the drug to one species or specimen, and they will give pacifier to another without telling them whether it's a drug or it's a pacifier, and then observe the impact statistically, and notice that whether drug is working or not based on these tests. Similarly, whether a feature is working or not, we do that using A/B testing. On the Amazon website, the color of submit button, the color of buy now button is basically done through A/B testing. Okay, we figured out that the color of buy now that you see on the Amazon, we launched many more variation of that buy now button with different colors, and observed which one is giving us sales. Okay, and based on that, we figured out that the current buy now button gives the maximum kind of sales. So that's how feature development on an e-commerce portal happened by the way of A/B testing. Here what you see is there are two variations, A and B. Variation A is red in color. Variation B is green in color. 50% of the visitors are being sent to variation A, while the other 50% are being sent to B. Question to you is, which one will you go for, the red or the green, based on this data? Red, right? Because the red one is giving us 23% sales out of 100 people, or out of 100 visitors. Let's say there are 200 visitors. 100 visitors are seeing the variation A, other 100 visitors are seeing the variation B, and out of 100 visitors, 23% are buying here, but only 11% are buying here. Therefore, therefore, we would go for the red color. There is no doubt about it. Provided this data is statistically significant. The more number of visitors are there, the better this will be. And the better this would be. And as a matter of fact, this A/B testing doesn't really happen on 50% each. We run variations, the new changes on very small traffic, say 0.01% of visitors, and observe the conversion rate. Okay, so this is A/B testing. A/B testing is hugely impacted by big data. The more the users, the better it is. Okay, the more the users, the better it is. So big data, basically, if you have humongous data, you can do a better testing. Now, so this was e-commerce. There are many other users of big data, such as government. Government is a big user of big data related systems. Why? Because everything in government is big data, whether because it's a sheer population, and even for if even for one person, we are storing 1 megabyte of data, and there are say 100 million people, it's going to be really huge. So everything related to government is a big data, be it fraud detection, be it cybersecurity welfare, be it justice, and so on. Okay, so this is so the other customer of the big data is telecom. So these are only few ones, but that doesn't mean that if your company is not in any of these verticals, you can't have big data problems. You can. Okay, so a question from Noor is, so moving to your movie example, if there would be two common movies, half of the users will show the first common movie as recommendation, and other half the second movie, and then based on the conversion, we will know what is the best recommended movie. Yes, that is the next step. So we combine the recommendations with A/B testing, and that's how the recommendation or collaborative filtering coupled with A/B testing gives a great feedback loop, and that's how we generally judge. But remember that in the beginning we do not start recommending, we do not start taking feedback so quickly, because what happens is it becomes a self-prophecy. If self-prophecy as in, we had small data, we generated some recommendations, now we are showing it above, and when people are clicking on it because it was above in the top, and it's further getting clicked, and therefore we are saying that this movie is really really good. So those kind of things do happen when we combine the two. All right, good question. Okay, so a question from Kanji is, please explain an example of how to combine A/B testing with Noor's question. So here, coming back to the question again, let me go back here. Okay, imagine that we are showing these recommendations here, right? And these recommendations are generated based on the statistics. Now, you want to observe whether the recommendation generated is really great or not. Okay, so what we'll do is we will put a feedback loop here using A/B testing. Using A/B testing, we will put a feedback loop saying if this is getting clicked, that means our this kind of recommendation is doing good. Okay, and that's how we generally stitch the solutions. So we start with recommendations, and then we combine the feedback loop data to give better recommendations. All right. So that's like next generation of the. A question from Shailesh. Can big data be used in real-time applications? Let's say tracking of criminal faces across the globe in real time. It can be done. I mean, it's not big data that's going to be used. It is a big data problem, definitely. It is big data problem, definitely. And big data is not going to do anything for you, right? It's you who has to build the solution like that. And you will have to utilize the big data architectures and big data algorithms. All right. So yes, using these systems like the MLlib, the machine learning library provider Spark, as well as the Hadoop stack, you can definitely build one of such variation. Okay. But it is going to be really, really hard problem. All right. So great. Now, the telecom, since in telecom also everything is big data problem, be it customer churn prevention, be it network performance optimization, be it calling data record analysis, or analyzing the network to predict failures. Okay, telecommunication, when we say telecommunication, we are all right. Let me come back. So telecommunication is what? Basically, the telecom providers such as Vodafone, right? Vodafone, AT&T. So in their case, they can prevent the customer churn. Customer churn means customers leaving them. How can they do that? And they actually do that by observing the history of individual users and then combining them together, that these users left, these users are still with us, and so on. So if they do that calculation on humongous data, they'll be able to figure out why the customers are leaving. Okay, did they, how many calls did they make before leaving their network, how many times they try to reach, for how long their network was out of coverage area, and so on. The second point in telecom is network performance optimization. If they do the analysis of the network, they can optimize the performance of the network. Okay, like for example, if they figure out that on Sunday and Saturday, this is the area in which there's more traffic, therefore they can accordingly allocate the resources. The calling data record analysis is another complex problem to identify the 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 patterns in the calling records, calling rate, calling behavior of the users. And also, if they could, actually they are already doing it. So if they could analyze the network, that this was the state of network when last time it failed, then they can predict the network failure before it actually happens. All right. All right. So a question from Vinda is that, is an algorithm with a mathematical model expression? Yes. All right. Now going ahead. So government and telecom are another big data customers. Few examples of big data customers. The anything related to healthcare and life sciences is of course a big data problem, because whether it's health information exchange or whether it's gene sequencing, the amount of data storage or processing all are all are complex and huge, right? So if you have a health information exchange, as I told earlier, that for 100 million people, if you have to store even say half gigabyte data, is going to be humongous storage. And again, transferring that amount of data is a complex problem, because of many parties involved, because of the data security, because of the encryptions involved, and so on. The second one is gene sequencing. Gene sequencing is a hard problem. You need to try all kinds of permutation. And this again, in this again, the CPU as well as the other resources become the bottleneck. The third problem is healthcare improvement. So if we are trying to do A/B testing, or if we are trying to observe all kinds of environments which are causing the healthcare problems, then it's going to be a big data problem. Then the drug safety. The drug safety is again kind of A/B testing on a large scale. So drug safety is again a big data problem. So this is about the big data problem. So should we take a break for 30 minutes? Sorry, 10 minutes? Break for 10 minutes. Back by 9:40 p.m. IST. Please post the time in your time zone. All right, please post the time in your time zone so that you can help others who are from your. All right, let me just put note here. All right, let's take a 10 minutes break and I'll be back by 9:40 p.m. Let me make it 9:41. All right, so I'm back. Should we start now? All right, so great, great, great to have a great to have a great audience today. All right, so far what we have discussed is we understood that what does it mean by big data. We also understood that why why big data now, and we also understood the use cases of big data. All right, so the answer is extremely simple. Answer is extremely simple. More the data, better would be the predictions, better would be the analysis, right? Bigger the data, better would be the prediction and better would be the analysis. And just that when the data is bigger, we find it hard to use existing systems. And that's where this new genre of computing has come into play. All right. That's why we need to learn this new genre of tools and new genre of techniques in order to process really huge data. Okay, so and we also talked about the various use cases in various verticals. Now, let's talk about the solutions. Let's talk about the solutions related to big data. Okay, so how do we achieve the solutions which can handle volume, velocity, and variety in data? What are those solutions? There are many solutions as of today. There are many solutions as of today. Some of them I'm putting it here. First one is, say, a combination of Hadoop and Spark. Okay, Hadoop provides a good amount of way of storing data, while Spark can do a great processing on top of the Hadoop. Okay. The second part is the NoSQL data stores. These are the NoSQL data stores. And what is NoSQL data stores? These are the new form of storages, new form of SQLs that can run on top of many computers. Hadoop and Spark both can run on top of many computers, and that's the reason why we talk about them when we talk about big data, because they both are for the distributed computing, all right, to utilize multiple computers to solve a problem. So Cassandra and MongoDB are the examples of something called NoSQL. NoSQLs are nothing but kind of databases, kind of data stores in the form of key values and not really relational. And they both utilize multiple computers in order to achieve velocity and volume, and sometimes also variety. All right. So, all right. A question is, what about R? What about R? R basically doesn't fit into the big data landscape, though there are versions of R which run on multiple computers, but it's not so production ready yet. All right. There is a version of Spark, a component of Spark called Spark R. R is nothing but a normal programming language or interactive programming language to specifically process data. But since R runs on single computer, if the data is not fitting into the memory, we can't really use R. All right. And that's where the new genre of tools come into play. A question is, what database with big data deal with? All right. Now, here, these are the examples of data stores. And here we are talking about Cassandra and MongoDB. The Cassandra and MongoDB are basically Cassandra and MongoDB are basically examples of NoSQL stores, and there is HBase provided by Hadoop for the same thing. In order to provide high performance, as in many users can write data simultaneously at very fast pace. That's what are these NoSQLs. Along with that, they can also do the processing, basic processing using them. Now, the fourth and fifth is something where if we can push our data from our premise to some cloud hosting, cloud is nothing but computer at somebody else's place. And if you could push our data from our if we are allowed to do that, if we can take the data from our premise and put it on Google's cloud, Amazon's cloud, or Microsoft's cloud, or IBM's cloud, then this is something that we would like to go for. All right. So Google Compute Engine and AWS, they provide the out-of-the-box capability to store humongous data, but it is generally more costly. But the headache of maintaining the hardware is absorbed by Google and Amazon. Okay, so Google Compute Engine or Amazon Web Services are example of hosted solutions to handle big data. Hosted solutions to handle big data. So these are just few solutions to handle big data. Just few example or few architectures or few tools to handle big data. All right. So here there could be Microsoft Azure, there is the sixth one, then seventh one could be IBM, and so on. Right. So but we will, since Hadoop and Spark combination is probably the most robust out of it because it allows us to create our own cluster, let us do the entire computing by ourselves, we will learn this part. This is more cost effective as well as it gives us more control over our data. So generally, the organizations which are not able to, who don't have too much of data, they generally prefer the cloud-based hosting such as Google or Amazon. But the organizations who do not want to go with them, they would like to create their own big data solution, and generally they choose Hadoop and Spark's combination. Also, if your data is really, really huge, say in case of InMobi, we were generating terabytes of data every day. And in that case, it was impossible for us to upload the data to AWS or Google Compute Engine, or it wasn't cost effective. So we were maintaining our own Hadoop cluster. All right. So these are the few examples of tools to handle big data. All right. A question is, which components of 1 to 5 do we need to begin working in the big data space? My simple answer would be Spark combined with Hadoop. Okay. Now, question from Minda is, what is a database system? Database system is like Oracle, Microsoft SQL, MySQL, and others. Database systems are traditionally database systems are some systems which provide you the tabular kind of format in which you could store data, and you could run queries on those. So those were database systems. Question from Sankar. I understood that Hive is used for data analysis. What is the use of Pig? Let's answer this after a while. Okay. Question from Noor is, are these solutions to provide only big data storage on distributed, or is it more than that? It does not only provide big data storage, these also provide processing on top of big data, right? So most of these systems, what they do is they slice the data and distribute it on many computers, and to do the processing on such kind of distributed environment, it's better to distribute the computing instead of bringing the data together. And that's why all of these components provide a way to process data on the distributed storage. We'll talk about that later because that's really, really important and complex topic. So we would go step by step into that direction. Question from Inma is that can't we use Hadoop and Spark on any cloud-based hosted infrastructure? Of course you can. Of course you can. As a matter of fact, Cloudxlab is hosted on the AWS. That's right, Myanmar. So the fact is that 4 and 5 are not really solutions, but platforms where you could build your own big data solution. That's I totally agree with you. But since there is no better way to put them, we are trying to solve the problem of big data. That's why we're calling them big data solutions. A question from Minta. Are SAS, SQL, SQLite, SQL solutions, MSX's database system? So, and what is their difference? So SAS, SQL, SQLite, SQL Solutions, and MS Access all are single computer based, while MongoDB can run in distributed way. That is the main difference. And other than data being unstructured and so on. So, so in case of SQL and most of these data systems, they handle the structured data. A question from Sheshadri, are there any other use cases where we can use these solutions and need not be only for big data? So, all right, a question from Sheshadri is, are there use cases of these systems where we could use these solutions, not only for big data? So I'll tell you this. So even if you don't have big data, the case of Google Compute Engine and AWS is definitely there. They basically resolve your hardware kind of work. So platform that definitely can be used. While if your data is, and in case of MongoDB, MongoDB helps you storing the larger objects. So definitely that too can be used in case of smaller data. But if you are trying to store smaller data, let's say we have really small data that can easily be done on one computer, and you try to utilize Hadoop and Spark, then this is not going to give you great performance. Okay. All right. A question from Anil is, what is the level of consistency in distributed computing working with big data? Very good question, Anil. So when we are dividing the work amongst many computers, what happens is, let's say you are creating a database table and many computers are basically serving that table to the users, right? Serving some data to the users. So generally, most of the databases, whether it's MongoDB or Cassandra, they're not able to provide a strong consistency. They are able to provide distributed consistency. Okay, so you can take a look at the NoSQL sessions that we have posted, so you'll get the answer to this question. All right, good question. A question from Deepa is, what about Teradata? Teradata is good for storage, but I'm not sure if they can they do the distributed computing. All right. Question from Kenji is, will we learn how to create these clusters even though they are already in Cloudxlab so that we can learn how to be a Hadoop and Spark admin? So in that case, what we do is those who are interested to learn how to become the admin, we generally provide the guidelines that we followed in order to set up Cloudxlab. All right. A question from Binta is, I hear about Informatica, what it is. You remember we talked about ETL, where we were converting unstructured data to structured data. So Informatica provides ETL tool, a robust ETL tool. A question from CP. Yes, Teradata do distributed processing, but it can process 10 terabyte of data at a time, and also it is costly. Thank you, CP, for that information. I wasn't aware of that. All right, great. Shailesh, I missed the Android app part. Great set of questions. Keep the questions coming. That is the only way to learn anything. Okay, you're not stopping others by asking question. You're probably helping them because they might have the same question, but they're not just framing it or not able to put it forth. Okay, so our sessions are about getting your questions answered. All right, today we have close to 100 audience 100 attendees, so we are kind of moving fast in answering the questions, but in our usual session, we make sure that everybody's questions are answered. All right. And that's the reason we basically make, even if we have to take extra classes, we take extra classes. We are okay in spilling over the class to more sessions, but we are not okay with skipping the questions. All right, there's no question as bad question. There's no question as dumb question. Every question is relevant. So, and we, as part of these sessions, we also learn to be patient with each other and learn to answer even the simple looking question. All right. So feel free to ask questions as much as possible, and that's the way to learn. All right. Question from Michelle. Is there an ETL tool to transform Hadoop data to be processed in Spark? Yes, of course. Spark can handle all the data which is stored in Hadoop file system. Okay. Can we use Spark with MongoDB? Yes, you can use Spark with MongoDB to do fast processing or transforming and again writing into database. Okay, there are two questions. First is, can we use Spark with MongoDB? Yes, you can. Now, question is, to do fast processing or transforming and again write into database, is it right choice? I would say that no, it's not right choice. I would say that use a normal file system to to store the results from the Spark, and that will be better. I'll talk about this in a while. I'll to take you to the whole architecture, and I think it's a time is there now to go to the next step. Okay. All right. I think most of these questions will be answered now. Okay. Just one more question. Okay. I'll answer these questions after the session. Okay. Feel free to retract these questions if they get answered as and when. So let me just move ahead and answer the question. All right, so I think let me just take you over to both the architectures of Hadoop and Spark. And by the end of it, you will get the clear picture of what each component does. Okay. All right, because you guys are moving ahead. So, okay, there is no option to retract the question. All right, no worries, no worries. So we'll take care of. All right. All right, so what is Hadoop? What is Hadoop? Hadoop is basically, let me give you a brief history. Hadoop was created by Doc Cutting, who was working at Yahoo at that point of time, and he was trying to build a search engine similar to Google. And, and the search engine was called Nudge. But they were stuck with along with Mike Cafarella joined Doc Cutting, and they were trying to build this search engine. Now they were both stuck at the point where they were trying to crawl the data, and they realized that using existing file system, it's not possible. It's not possible using existing file system. And that's where they that's where they were stuck, because storing the data from all over the world in order to build the search engine is is really impossible using existing tools. So at the same time, Google published their papers called Google File System, Google MapReduce, and Google Bigtable. So Doc Cutting and Mike Cafarella implemented the three papers, and that's what became Hadoop. Okay, so Hadoop was named after the toy elephant of Doc Cutting's son, and Hadoop was kept open source, and that too with Apache license. What is Apache? Apache is a license, kind of a license. Okay, so Apache Hadoop was started with these three components. Hadoop file system, which is Google file system, became Hadoop file system because they implemented the paper, and Google MapReduce, the paper on Google MapReduce was implemented and was called Hadoop MapReduce, and Google was Bigtable was called HBase. So they are not clone of Google's products; they are just implementations of what they wrote in those papers. Okay, so Hadoop as of today is, it being open source, is available to everybody. You can use Hadoop in all kinds of use cases. Hadoop is provided by many providers who provide the support with it. For example, Hortonworks and Cloudera, they bundle the same open source Hadoop into their packages, but Hadoop is open source and free. There is no licensing required in order to use Hadoop in your organization. All right. The the Hortonworks or Cloudera or MapReduce or Qbol, they are just providing the support around Hadoop, and they are also putting bells and whistles around the open source Hadoop. All right. And Hadoop is powerful, popular, and well supported. It's a framework to handle big data. After a while, Hadoop kind of became, it started with these three components. Then, after a while, it became kind of an umbrella of products or suite of products. And all these products were, all these other products that came under the umbrella of Hadoop were all for distributed, scalable, and reliable computing. What does it mean by distributed, scalable, and reliable computing? It means that if you want to divide the work amongst many computers, that's distributed. Scalable means today you are using 10 computers, tomorrow you might want to use 100 computers, so it should be possible to use more computers as and when we want it. And reliable, as in if some of the computers stop functioning, then also it should work. That is distributed, scalable, and reliable computing. And most of these components, almost all of these components which are under the Apache Hadoop umbrella are written in Java. So Costel's question is, so Google just published the papers without implementation. They wrote the implementation details in the paper, but they did not publish exact code. All right. So those papers are publicly widely available. And yes. All right. Now, so this is Hadoop. Hadoop is basically bundle of components. And here is the stack. Okay, so the first and foremost in this stack is the file storage. Hadoop distributed file storage. File storage is what? What do you understand by file storage? Like when we go to this, I'll show you. So If I open my folder, this is file storage. This is the file storage. And so this is the file storage because we are storing files here. And in this Hadoop distributed file storage, we have the many computers having many hard disks contributing the storage. So Hadoop distributed file system is not like our usual file system. Instead, the file system spreads to many computers. So it utilizes, it utilizes many computers in order to provide you the storage. You as a user does not do not need to know where is your data. All you need to care about is this was my file, I put it into Hadoop distributed file system. You don't have to deal with half of the file I'll put in this folder, half of the file I'll put somewhere else. That complexity is absorbed by Hadoop distributed file system. Do you remember the days when you have multiple hard disks in the computer? You used to keep some movies in one hard disk, some movies in another. That kind of complexity is very well resolved by Hadoop distributed file system by combining multiple machines into multiple machines storage into a single layer. Okay, I'll like to show you right away before it becomes too theoretical. And all right, let me just open. Okay, let me just open Cloudxlab. How does Cloudxlab looks like? I'm going to log into Cloudxlab. Okay, so if you go to say my lab, you will be able to see the lab credentials along with these. You'll be able to see lab credentials, and what you see here is the say Ambari here, and say Hue. So again, let me give you a quick heads up. So we are using at Cloudxlab, we are using Hortonworks version of Hadoop, and we have taken all the components from Cloudera and installed them on top of it. Okay, Hortonworks provide something called Ambari, which helps you install Hadoop in the cluster so that we don't have to install manually on all the machines. Okay, so what you see is all of these components are here, and we have these many computers on which we have installed Hadoop. The last one is stopped. Okay, and these are the remaining computers which are working right now. So using these many computers, Hadoop is able to provide us the the file system and other things. So if we go into Hue is a file storage files browser provided by Cloudera on top of HDFS. It's just web interface that is nicely provided by as a web application. So this file system looks like this. Okay, the file system looks like this. All of the file system is single. So here is some of the data set that we have kept for our users, and some of the data sets are here. So you can see that the file system looks like the HDFS looks like our normal file system, right? Normal file system. It has folders, it has files, it has everybody's home folder, and so on, right? So the Hadoop file system, HDFS, is just like any other file system. The only difference is that these files that you see here nicely, some of these would be on one computer, some of these would be on another, and there will be a backup, of course, and so on. So this we will talk about exact architecture. We have already talked about exact architecture in our HDFS course. So you can take a look at our Hadoop course, and you can maybe take a self-paced or maybe sign up for the full course. You'll be able to learn how exactly Hadoop is able to provide you this singular file system using many computers. All right. So Hadoop distributed file system is a file storage which utilizes many computers, many hard disks. Now, on top of Hadoop distributed file system, we have something called yarn. Now, when the data is distributed onto multiple computers, the we need a way to execute things on these computers. And that's what yarn is. Yarn is basically like an operating system sitting on top of the file system and executing things as and when we demand. So yarn is basically the resource manager and is tracking which computer is busy, which computer is free, which computer has run, which computer it should be used for next computation. So yarn takes care of that. So we give the program to yarn and we tell the yarn that, hey, get our work done nearer to this data. So yarn will execute that and run it nearer to the data. All right, that's our resource manager called yarn. Now we have something called HBase. So what we learned in case of HDFS was we can store data in the form of folders and files, right? But if we have to store data in the form of tables, which has rows and which has columns, we can't do that using a file system. If we try to use, say, CSV file or other file format in HDFS, it won't be that robust, right? Because in case of CSV file, if you want to delete a record, you will have to rewrite the entire file, right? Therefore, HBase was created. HBase, what is HBase? HBase is kind of a database. It provides you a column and row kind of a structure in which you could store data. And it's basically a NoSQL data store. I'll show you a quick view into our HBase. So here you'll see data browsers and I'm clicking on HBase. So this is a UI for HBase. You can also programmatically talk to HBase as well as from the console, you can talk to HBase. All right. So HBase is basically um, a data store. It has rows and it has columns. Okay. So this is just one example in which we are demonstrating you a very simple example having two rows and two columns and two column families. Okay. Now, that was HBase. HBase is basically a way to create record-based systems on top of Hadoop. HBase internally is using HDFS. Okay, HBase internally is using HDFS. So we have got file storage, we have got operating system which could execute anything, or resource manager which could execute our programs. We got NoSQL data store called HBase. So now, third one is a compute engine such as MapReduce or Spark. What do these do? MapReduce was first way of distributing your computation. Instead of we deciding that first run this program, then get this data, then do that, instead of all of that juggling, instead of writing our own program for yarn, we use MapReduce. MapReduce makes it possible to write only the logic that we require. Rest of the work is handled by MapReduce framework for us. So we write two things, just like we write SQL queries. In the same way, we just write our logic in the form of map and reduce. And the MapReduce framework creates the entire work. It does the sorting of data, it does the heavyweight lifting of everything, and and executes its logic using yarn. So MapReduce uses yarn. Yarn also talks to Hadoop file system. MapReduce also talks to Hadoop file system, and so on. So basically, MapReduce is a framework which takes the map and reduce from you, just like in group by we hand over the group by query to the database. In the same way, MapReduce takes the query from us in it's just that query is in the form of small pieces of two pieces of code, map and reduce, and it runs that nearer to the data and gives us result. Okay, so MapReduce, the exact execution is done by yarn because MapReduce does not track the resources. Earlier in the Hadoop version 1, both of these components, MapReduce as well as yarn, were single component. But in the Hadoop 2, they split these two components and these two things separate. Okay, so earlier MapReduce plus yarn were the same component. Okay, so compute engine now is a separate one, and therefore, and this basically in the second Hadoop 2 design, the resource manager became really powerful and useful system. It gave place to new computation engines such as Spark. Okay, Spark is a competitor to MapReduce. It lets us distribute the work on yarn cluster. Okay, so we program to Spark. We write our programs and give it to Spark. Spark runs those programs nearer to the data via yarn. Okay, so we generally interact when we want to do processing, we interact with MapReduce or Spark, but when we want to read or write data directly, then we directly talk to file system. Or if we want to do the record-based processing, or we want to add records, update records, delete a particular cell, and so on, that kind of work is very much possible using HBase. Now, the next part was Spark, as I told you. Spark is again a competitor of MapReduce, really, really fast version of MapReduce. And since it was not always possible to write the code in MapReduce, because in MapReduce, you had to write code for everything. Therefore, Hive came into play. What Hive did was it took SQL from you and executed MapReduce here. So you write SQL, you give to Hive, Hive runs it on MapReduce, and MapReduce basically runs it on Yarn and so on. Okay, so Hive is a great SQL interface and is very much in the production because it's not always wise to start writing code even for very simple things like joining two tables. Okay, therefore Hive made the life really easy if you want to process structured data. For structured data processing, Hive is the way to go. All right. If your data is unstructured, you can't really use Hive. Instead, you will use the file system. All right. Now, Pig Latin was another optimistic project in which it was, though it did work out in the beginning, but soon enough it started showing the limitation. Pig Latin was similar to Hive. It has its own query language called Latin, and we would write queries in the form of a Pig Latin and then give it to Pig, and it will translate to MapReduce and run it. So Pig Latin was very similar to Hive, just that it used a different language. So Pig Latin took Latin from you, as in it provided its own query language, and you had to write code in that. It's no longer, we are not, though we have this as part of our self-paced course, but we have removed this from our curriculum. All right. Mahat again was a great library for machine learning on MapReduce. So when we have really complex problems, such as finding recommendations on terabytes of data, when we have to do complex computing, then we have ready-made algorithms available in Mahat. Instead of rewriting that whole logic about recommendation, we use the libraries such as Mahat. And you'll be surprised to know that the recommendation logic part of my project was actually pretty small. Even though the project was of recommendation, maximum work was translating data from one form to another. So Mahat basically is a machine learning library. It contains many algorithms, and it also provides statistical algorithms for us so that we can do processing of large amount of data. But Mahat is again kind of being rewritten on Spark. So because map whatever work we did in Mahat, we are nowadays doing using Spark MLA. So Mahat again has been removed from the curriculum. All right. So the workflow, the when we have a big project, we generally do many things in the work. Okay. And there are two tools that we have not discussed: Flume and Scoop. What does Flume do? Flume basically Flume basically processes unstructured data. Flume processes unstructured data. It takes the raw data and it takes the raw data and and basically transmits it to the HDFS. So sorry, let me go back what I was saying. So Flume basically transports a lot of data, not transports a lot of unstructured data from one place to another. Generally, Flume is used in the case, let's say you have 50 web servers and you want to copy the the data being generated by these web servers continuously into HDFS, then you use Flume. So Flume is basically an engine to transport data, unstructured data. And if you have structured data, say you have already, your organization is already using data warehouse, and your organization is already using databases such as uh, Oracle, Microsoft SQL, MySQL, or Postgres, you will be you can use Scoop to copy the data from your structured data sources into HDFS. So using Scoop, you can transport the data from non-Hadoop systems to Hadoop. Okay, so these two tools are quite useful to get started with big data, because you will be moving your data from existing systems to Hadoop ecosystem. All right. So once you have a project, you will be using many such components, and that's where the workflow tool such as Oozie comes into play. Using Oozie, we can say that first copy the data using Flume, then copy the data using Scoop, then run our some HDFS command, create some HDFS folders, and then do something on Yarn and do something using Hive, do something with HBase and so on. So all of this can be sequentially storyboarded using Oozie. Oozie is our workflow manager. All right. All right. A question from Noor is, this big data structure looks complex, big and complex. So how many roles we normally have in big data? Example, big data developer, analyst, or administrator. Okay. So I'll answer this question. So though these things just look too many, but they are actually pretty simple and not too big. And therefore, we basically cover all of this in a 30-hour session. Okay, so in 10 sessions of 3 hours each, this is what is covered. All right, so it's very important to know that these tools are extremely simple to use, and it's just that we should know how to use them. All right. And the big data developer or data engineer or analyst need to know this ecosystem. At data admins, even the big data admins need to know this ecosystem. Okay. All right. Let me try to answer. answer a few more questions. Okay, great. Let me answer a few more questions. Question from Sankar. In Hadoop ecosystem, nowhere data will be stored except HDFS. Is there my understanding correct? Yes, use most of these systems use most of these systems use the HDFS directly or indirectly. But there are few more systems that we need to know, which are not mentioned in this, but they are covered in the class. One of such system is Zookeeper. Zookeeper is used by many systems for coordination. Okay, and there is Kafka, which is used as a queue. Okay, so so basically most of these systems are going to use HDFS directly or indirectly, but there are few more systems such as say Kafka, which is separate from Hadoop. But Zookeeper is something that is used by Hadoop. We discussed that Zookeeper session earlier in the session 1 of Hadoop, which basically provides coordination between multiple systems. The other place where some of the data is stored is probably in one of the MySQL databases. The Hive that you see here stores some amount of data in MySQL. It stores some amount of data in MySQL. Okay, so now a question from RDHAVLE. I'm sorry, I could not pronounce it. All right. So, will you explain all the technologies and tools involved using one real-time example throughout the course? Yes. We will actually take multiple examples. We'll take multiple problems and we'll try to solve those. Okay. A question from here is that a way to optimize query like in Oracle and optimize the speed? Yes. Hive does provide you a way to find the various numbers and try to understand, diagnose the queries. Okay, so Hive does provide that. Question is, should a big data engineer jump into data science with few years of experience for better career opportunities? Yes, you can. A question from Indrajit. When we need to run Zookeeper? Okay, very interesting question. So Zookeeper is used globally by all of them. Okay, so Zookeeper is kind of assumed to be running in Hadoop cluster. So all these tools, whether HBase, Yarn, or even Hive, all of these systems coordinate amongst themselves using Zookeeper. Okay. Question from Hari. A data scientist should learn these due to availability of AWS and Azure cloud. Should we learn big data or not required? So my point is that at least what you should learn is how to distribute your computing. That is the most important task. Rest of the tasks in this whole ecosystem are really easy, but converting your program into a distributed system is something tricky and hard. Okay, therefore I generally suggest that if you are comfortable with rest of the ecosystem of uploading, downloading data and so on, you should at least learn how to distribute the computing, because that has a learning curve. Remaining systems, as you start working, you can learn. Question from Noor. Where is Zookeeper in the ecosystem? Zookeeper kind of is common to all, is used by everybody. A question from Raghu: what is the real use case of HBase when all data is stored in HDFS? As I was telling you that, right, so your computer has a file system, right? Your computer has folders, files, you can create, upload file, correct? And you also have databases, right? Like MySQL, Microsoft SQL. And these databases store data in the local file system, right? So when you have this, then if you take a look at the database is storing data into your file system. So question is, why do we need database when you already have file system? The answer is to store data in the records format, in the tabular format, okay? Because if you try to do that in HDFS, it's going to be extremely inefficient. Okay, that the technique to store data in the record format in the HDFS and still being fast is something that's provided by HBase. A question from Kanji: this whole ecosystem seems overwhelming. How much in depth would you explain each portion, and would we know enough to gain employment in this space? So we actually go into very high details about these components, into quite depth. You will understand all of these parts. And to gain the employment, you need to know how to use these components. Okay, and that's it. So that would be good enough. Yes, we will explain we'll explain these resource manager, job tracker, and task trackers in details in the class. Today it will be a little harder to do because there are just too many things to explain. Question from MN Amin: could you please mention the working area of data scientists and big data experts? So data scientists generally take care of the both sides of problems. They take care of the data related as well as machine learning related problems. So data scientists basically kind of take care of both sides, while big data experts take care of the data processing part. Okay. Question is, so what about Flink, Spark Flink, or Mars Reduce? Mm, so, I mean, they are also some of the analytics systems, and they do provide the analytics on top of big data. But will kind of be confined to the Spark and Hadoop ecosystems. If we understand, learn this ecosystem with this course, what are the chances that we would be able to crack an interview or get a job or make a career shift? In my experience in past, quite a few engineers have been able to do that successfully. So I would suggest that this would be probably the best course. And when I say this, I mean it. And to be able to learn to solve big data problems. All right. So, and when you are able to solve the big data problems, cracking the interview or getting a job will not be very difficult. A question from Kanji: is knowing both big data and data science optimum? Yes. Okay. So if you really want to be a data scientist, you might have to know big data as well as machine learning. Question from Sailesh: does Zookeeper need to be running on all nodes? Yes, it does. All right. How is SAP related to big data and data science? SAP is also trying to provide all kinds of storages like HANA and others, and they are also trying to provide the big data ecosystem and data science ecosystem. Will you provide projects after the course? Yes, we do. From the curriculum, it looks like course is more focused towards Spark and Scala. Is that not true? Question, very good question. Uh, I was actually coming to that. So this is something called Hadoop ecosystem, right? I wanted to describe it so that when we talk about Spark, it is covered because Spark depends partly on the Hadoop ecosystem. Say, for example, most of the big data is stored in Hadoop and Spark does not provide a way of storage. Similarly, when Spark is using Hadoop file system, Spark will be basically getting the work done via yarn. If we are processing data stored in HDFS, then Spark will be using yarn to process and distribute the work here. Okay, so that's the reason why I went over the entire Hadoop ecosystem, even though the course is about Spark and Scala. All right. I hope that answers your question. Question from Noor is, we will understand the big data ecosystem fully, but what is big data engineer? What does big data engineer do? Okay. And what is his day-to-day role is, can you elaborate with an example? So big data engineer's role is to be able to handle big data. Let me take a proper case, the one which I can explain better. Say the role my role at InMobi was to create recommendation engine, right? So we were having a couple of big data engineers in the team. So what we had to do was we had to figure out a strategy on how to where to get the data, how to store that data, and how to translate that data, translate that raw data into something that can be fed to the algorithm. Okay, so we were using Mahat at that time. So we basically took that, and so we had to plan out entire thing. So we had to clean the data. Data was in the form of the web server logs. We had to take the raw data from the web server logs, clean it up, make it records, figure out the user ID, figure out the product ID, figure out how much is this user playing that game, and so on. So cleaning the data, making it ready for feeding to algorithm is something big data engineer has to learn. Okay, while deciding upon algorithm or designing upon algorithm is something most of the ML scientists, machine learning scientists do, and therefore the role of big data engineer is humongous, because in a project 95% of the work is to be able to clean and make the data ready. Therefore, the 95% of the project is actually big data engineers work. Okay, can I get a job by learning Spark and Scala? Yes. If you take a look at the trends, you'll find that Spark and Scala is probably the hottest skill. Do we have to pay for next upcoming session, or is it free? So this is session one. So session ones are free, and the other parts are paid. All right. There are a few more questions. Let me just take them quickly. Any idea about data lake? Basically, a place where we put all kinds of data is called data lake, and HDFS is one such data lake. Okay. Why don't you use Python and Spark? We can definitely use Python and Spark. There is nothing stopping it. Just that since Spark is written in Scala, so we thought that we would better use learn Scala along with Spark. Okay. So what is Scala? Scala is kind of Python version of Java. Basically, they have tried to make it as simple as Python. Okay, they have tried to make Java as simple as Python, and therefore we are using Scala with Spark. All right, there are a few more questions that I need to answer. All right, so let me just answer a few more questions and then we will move on to Spark Stack. Question is, how would Hadoop be used on the cloud that dynamically allocates resources? So basically the resource allocation will be handed over to the to the Hadoop's yarn. The way we are doing at Cloudxlab, we have taken the dedicated servers and we're using those dedicated servers to process data. Okay. All right. So even though you don't have a control over drives, but you can always choose the dedicated drives the way we have done. We have taken the dedicated drives and that gives it good performance. So what is the difference between Scoop, Flume, and Kafka? Scoop basically helps us transporting data from the databases to HDFS, Hive, and HBase, while Flume helps us transporting unstructured data, and Kafka is a full pipeline, is a big pipe of data in which on one end you can write data, from other end you can read data. So Kafka is used as organizational queue. Okay, we will talk about Kafka during one of the sessions in this course. In this course, we talk about Kafka when we do the Spark streaming. So we will use Spark to process data from Kafka. All right. I hope this question is answered, Sheshadri. So Flume is only used in Web to Hadoop. Not really. Flume can be used at many ways. Whenever you want to download a lot of data and continuously keep on pulling data and pushing into HDFS, we use Flume. Can Kafka be used to transfer both unstructured and structured data? And yes, it can handle both. What's special to Kafka? Kafka is a messaging queue for organization. We will talk in details about Kafka in Spark streaming session. Okay. A question in upcoming classes, are we going to study Scala, Spark, and Kafka in details? Yes, we will not be studying the Hadoop ecosystem. We will be studying the Spark, Scala, and Kafka in details in the upcoming session. Though our next Hadoop course will be starting soon in January, and those who are interested to learn Hadoop, they can join then, or you can sign up for self-paced course on Hadoop. We have recorded in the studio the course on Hadoop that you can attend to. All right. Can you compare your ML course to your Hadoop Spark course? If I'm planning to take both course, which do employees readily hire first? Okay, it's a really hard question. All right. It is based on your aspirations. If you are trying to become, say, machine learning engineers, if you want to get into machine learning, then ML course would be the right choice for you. If you are trying a career in big data engineer, you can take up Hadoop and Spark course. But if you are trying to take up a position of data scientist, then you might need to learn both parts. Okay. So that is my perspective of both the course. That's the reason why we are running both the courses. A question from Sankar, performance-wise, which one is fast, Python or Scala, and why? So Scala is faster than Python because Scala is using Java underneath, while Python is dynamic. So we'll talk about this during Scala discussion. All right. So quickly, Python is very dynamic and generic. So Python is slightly slower, while Scala is faster because there is no dynamic. It basically you define the data type upfront. Therefore, there's no casting and casting headache. So all right, is there a way to make it an interactive session where we can talk over the phone and ask you question? So in some of the sessions, when there are few students, we do that. We basically, in case somebody is finding it too hard to type, then they can generally unmute themselves and then they can ask questions over the voice. But what we found is that if people ask questions by unmuting themselves, they generally ask less questions. Okay. So in the normal session, because there are lesser students, we do not keep more than 20 students in a class. So you will be able to unmute yourself if others are okay. All right. So a question is, so as data engineer, I do not have to worry about underlying system, be it Hadoop or something else. As a data engineer, you will have to worry about underlying system. Uh, okay, because the data engineering is all about optimizing the data translation and transformation. So you will have to know the underlying. If you are using Hadoop, you will need to know a bit about Hadoop and understanding that how the data is distributed and why is it that I'm getting such a bad performance. And a number of problems that I recently solved with many of the people who are working in the area, what I found is that just because of their limited understanding of the distributedness, their solutions were very inefficient and mostly impractical because they were not utilizing many computers to solve their problem. Okay, so 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 what I believe is that as a data engineer, it's important to know the systems, like what is the objective of each system and how does the system function. Can we make it more interactive? Yes, we can make it more interactive. You can suggest me ways to make it more interactive. Sakti's question is why my question is not answered. I missed your question. Which question was yours? I think I just answered your question a minute later. A question is, how can I attend your offline session? So we don't have offline session. Even my neighbor has to attend my sessions online, and none of our courses are offline. So so you have to attend online. All right. And you'll find that learning online is far better and more focused than offline. Okay. And I have a numbers to show you that in couple of classroom sessions, the performance of students were actually pretty bad. Okay. Okay. And Salishi's question is, can we compare Spark and Storm? I'll just compare really quickly. Storm is good if you want to process data in less than a second time. Less than 1 second. If that is your expectation, go with the Storm. Otherwise, Spark is great. Okay. Question is, which book are we following with Spark and Scala? We're going to follow a book called Learning Spark. Okay. Learning Spark. And there are quite a few inputs from our side and from other sources. So those are varied sources. We will let you know as and when at the end of every session. How will we get to know about the next session? We will be emailing you. All right, so those were good questions. Let me give you a good overview of the Spark. So what is a Spark? A Spark is basically really fast MapReduce. It is really fast MapReduce. So it's around 100 times faster than MapReduce if it is using RAM. And of course, RAM is faster. So of course, Spark will be faster. It is 10 times faster than the disk. 10 times faster than MapReduce if we are utilizing disk. Okay, so Apache Spark is 10 times faster than MapReduce. It builds upon the similar paradigm as MapReduce, but it is extremely powerful paradigm. And as you learn, as you compare both the approaches, you'll find that writing program for Apache Spark is extremely simple and quick. Apache Spark is very well integrated with Hadoop. That also means that Apache Spark can run on other systems than Hadoop as well. All right, let me take you through the architecture quickly. Now, so Apache Spark, there is something called Apache Spark core. That's the main heart of Apache Spark. Okay, this core is responsible for defining a huge array. What is array? Array is list of element. So the core of Spark is about defining this big array, which is basically stored on many machines. So as an engineer, you will always think, or as a big data engineer, you will always think that it's a huge list, but parts of this huge list are on different machines. So that's the heart of the Spark core. Spark core provides operations on this huge list. You can define this list from all kinds of sources. You can define this list from HDFS, HBase, Hive, Tachyon, Cassandra. So this list is kind of a window to the data. So Spark core provides this something called RDD, resilient distributed data set. That is what is I was referring to as a list. So Spark core provides the ability to process data from all kinds of sources. Not only HDFS, it can also process the data from HBase, Hive, Tachyon, and Cassandra. Spark core can run on top of Yarn, the one that we just talked about. It can run on top of Amazon EC2. It can run standalone if you do not have any Hadoop installation, or if you do not have Amazon EC2, you can create your own cluster using Spark. If you have a less known cluster called Mesos, then also you can use Spark. Now, Spark Core provides these libraries which help you solve domain-specific problems or case-specific problems. So it has the library called data frame. So since the core of Spark is all around a huge array, huge list, it provides all the raw operation on that list. Okay, and and very often that very often we need to do common processing on that list. So Spark provided various high-level libraries on top of this raw library, right? Something called data frame, which let you process data just like R, just like SQL. It provided a tabular structure on which you could query the data. You can slice and process the data using data frames. So data frames are really powerful. Is a really powerful library of Spark. Okay, it is basically part of something called Spark SQL. It provides you this ability to process data distributedly and still use SQL. Then there is something called streaming. What is streaming? Using streaming, you can process data that is coming continuously to you. Data that is coming continuously. Let's say you want to continuously observe the trends on Twitter. Then you can use Spark Streaming to continuously pull the data from Twitter. Then we have a library called MLlib. What is MLlib? MLlib is machine learning library. It's the most sophisticated distributed machine learning library available. It's extremely powerful and efficient. So MLlib provides a way to do the machine learning using many computers. So Spark, in very simple words, Spark provides the framework to do the processing using multiple computers closer to the data. It lets you do the processing near to the data instead of transporting all the data somewhere and doing the computation there. Instead of that, it takes the logic from you and executes it near the data. And when we define the logic, we can define the logic in various forms. Either we could define the logic in the form of SQL queries using data frames, or if we are trying to process, say, graphs, a complex structures of graph, like finding paths from one place to another, in that case, we could use GraphX. the complex problems like finding the page rank, or finding in a graph of friends, finding who is the thought leader, you can use GraphX. GraphX provide you those wonderful libraries. So for doing the graph processing, the complex processing, you could use GraphX. For doing the machine learning, you could use MLlib. For doing the continuous processing, you could use the Spark streaming. And for processing data in the form of table structure, you could use data frame. And interesting part is you could have you could have a problem involving all of these, and still you could basically use the same mechanism. You could use the data created cleaning the after cleaning data frame using SQL. Same work can be given to MLlib, and then the recommendations can be generated. Okay, imagine that you want to generate recommendations. So what you have to do is take raw data, right? Take raw data. In that case, you will use Spark Core. Take raw data, convert that into data frame, and then clean that up, remove the records which are not really useful to you. And then once that's done, you can use the MLlib recommendations algorithm. So you can use all these libraries together to solve your problems, and many more. So Spark provides these sophisticated libraries, and and we're going to, as part of this course, we're going to talk about all these libraries. We're going to use all of these libraries, and the most important thing that we're going to learn is we are going to learn how to do distributed computing, how to translate a problem from the sequential computing, the way we think of for loop, the way we think about while loop. Instead of thinking that way, we will learn how to convert our problem statement, our algorithm, into distributed way, into something that can be run in parallel on many machines. Okay, and we will of course of course go over all of these libraries. We will take one use case of every library and learn it by the way of the use case. All right. So now the now the user, you can use Spark either using Scala, using Python, using Java, using Spark R, or using SQL. You can use Spark using any of these languages. That essentially proves to us that it doesn't make much difference learning a programming language. But so the first course that we delivered on Spark was using Python, but then we realized that people were more interested with Scala, so we moved on to Scala. Okay, and those who are interested in Python, I can give you an overview of Python way of using Spark. Maybe we can insert one dedicated session with Python on Spark. So we can maybe do that because some of us have been asking that now in this course. So we can do that as well. And but the course we had planned was with respect to Scala, because in Scala people because that's what it was in the demand mostly. Okay, so though there is a bit of performance that you will get using Scala, but truthfully speaking, in a big data project, the gains that you get because of language per se are lesser as compared to what you get out of properly distributing your computation. All right. So you can either go for this course, you could go to Cloudxlab and click on this one, or you can actually go for the individual course. I will show you. So you could actually go to scroll down a bit and you could go for Spark Developer course. Spark Developer course is what is starting today. This is the first session on the Apache Spark and Scala certified training, and it's going to be used. Okay, so you could use this to enroll for the course. I think there are 1 or 2 seats available as of now. Okay, in the course. All right, so okay, so that's about it. Let me answer your questions. All right. A question from Noor is, so why are we doing ML course in Python? Is it not possible to do ML course in Scala? Because the TensorFlow is available in Scala yet, is not, sorry, TensorFlow is not yet available in Scala, as well as the scikit-learn, the two libraries that we are going to use in machine learning are not available in Scala. That's the reason we are doing that in Python. But yes, but I think might have to rethink about the language choices. But in case you're interested in Python, do not worry. Do not worry. Scala is very much like Python, and it'll be completely okay with you. You'll be able to do Spark as well with Python. Trust me on that. It'll be completely okay. Our question is, can you speak in some detail about CCA 175? Is Spark plus Scala enough for seeing out this certification exam, or do we need to know both Hadoop and Hadoop in depth? Actually, you will have to know a bit of Hadoop in the Hadoop for CCA 175, but in CCA 175 is very hands-on kind of certification in that you'll need to know Scoop, Flume, and Uzi very well, and then you can try the CCA certificate, okay, along with Spark, okay. So Spark, Flume, Scoop, Uzi, and a bit of information about HDFS, so will be good enough for the CCA 175. Question is, do we get videos to learn Python? Yes, we will share that. Don't worry. In this course, we are going to cover Scala, and then we're going to Spark RDD. Then we're going to go detailed about Spark data frames, streaming. We'll learn Kafka. We will learn Spark R. We'll learn Spark SQL. We'll learn MLlib, and we'll learn GraphX as part of this course. So there are Spark libraries for all these languages. Yes, except for one, except for except for GraphX, which was only available in Scala. Rest of the libraries can be accessed from all the languages. But in Python, there is something called graph frames, which is basically same as GraphX, uh, GraphX wrapper, eh, okay, which can be used from Python. All right. So almost all libraries are available as part of this course. All libraries are available in Python. A question is, what is the difference between ML libraries of Spark and normal machine learning libraries? So a good question. Good question. Question is, we have many libraries of machine learning. We have scikit-learn, we have TensorFlow, and we have this MLlib in case of Apache Spark. So what's the difference? So MLlib is kind of rewritten scikit-learn. Scikit-learn is a library provided in Python for machine learning. And the difference is MLlib is a distributed version of it. Okay, you will understand as part of this course is that even computing average is a tricky thing if the data is distributed. If data is on multiple machines, even computing average is hard. Therefore, even the definition of the function average was rewritten in case of MLlib. Okay, and even every algorithm had to be broken down into distributed. Therefore, MLlib was rewritten. Okay, while scikit-learn utilizes single computer, while MLlib utilizes many computers. Question from Raghu, by learning MLlib, are we stepping into machine learning as well? In this course, we will take one or two examples of MLlib. We'll not go into details of machine learning. We'll take one recommendation example in MLlib that will make you acquainted with the libraries given by Apache Spark. So I will not say that this Apache Spark course is about machine learning. It is basically making you acquainted with the various libraries available so that You can dig deeper when needed. But this is not a machine learning course. This course is mostly on weekends. Question is, but if these can be made abstract, then normal ML solution can be easily ported to ML or big data without rewriting. Solutions can be ported, but the libraries had to be rewritten. All right. Ideas would remain same in both. So after taking this course, you will be able to solve big data problems using Spark. And you will my expectation is that you will become expert. Rest is your rest is how much work do you put with me. All right. There are a few questions. A question was related to Amazon EMR. So Amazon EMR as in here. I think that one I missed here. Okay. So Amazon EMR, if we are comparing with this MapReduce, Amazon EMR was basically MapReduce but done on Amazon. Okay. So it was elastic MapReduce in which you will write map and reduce instead of Hadoop taking it from you. It was Amazon's resources that were taking it. But if you are asking about the performance as compared to Spark, I can assure you that Apache Spark is faster than Amazon EMR. All right. S3 as data source. When we use Amazon EMR with S3, you don't really get data locality. Salish's question is data frame we can use, but data frame is immutable. Yes, we will cover that part as we go ahead with the course. Okay. If you take the Hadoop and Spark course, is the same course as Spark developer course? Yes, it is same course as Spark developer course. Okay. That's right, Dinesh. This course is good enough for clearing CCA 175 if you have gone through Hadoop ecosystem. Since this is about distributed computing, will networking knowledge help in to leverage our learning? Not really. You will learn that as we go ahead. Okay. So the amount of networking I'll help you learn, like what does it mean by services, how to launch your own service, how to connect to a network, all of that we will do hands-on and you will get it while we are at it. Okay. So whatever networking knowledge is required, we will help you learn that. The expectation is that you should be the expectation is not that you should be a network engineer. Are we going to get a project like building a data pipeline so we get hands-on? Yes, we'll do that as part of this course. A question from Sankar, when the course will end? It's going to take 10 more sessions from today. So it's going to be 11 sessions probably. So you can do a computation. There's going to be 1 week off during the Christmas. Okay. Yes, Raghu, that's right. It's good enough to crack the certification. A question is, I think Spark is installed on EMR now. So not really, not really. Spark is not installed on EMR because it runs on top of Amazon, but not on EMR. What is S3? S3 is the storage provided by Amazon to store files. Okay. Can Elasticsearch integrate with Spark? Yes, they can basically, you know, I mean, you will learn that once the data is processed with Spark, we can save it in HDFS, and from there, Elasticsearch can pick it. Did Spark provide API for Elasticsearch? This I'm not sure, but we can dig a little bit on it. Do companies require this certification prior to hire? Not always. Only the companies who have no way to measuring your skill generally rely on certifications. The companies which have the capability of taking your interview and checking whether you know it, they would not go with any certification. All right? They would basically ask you questions to solve. Dinesh's question is there a course for admin like big data admin? We do not have that course yet, and maybe we'll plan it in future. So, right. Our question is lab is separate from the session. So lab basically is something that you can take a subscription of. Every course gives you 3 months of lab. So if you are taking 2 courses, you can get 6 months of lab, and that way, which is actually good enough for you to learn. Even so, lab is shared amongst all. So whether you are learning machine learning or Spark and Scala, your data will be at the same place, and all the tools will be available to you. So if you are trying to combine, say, a machine learning algorithm and the Spark and Hadoop, you can do that because all the tools are available to you. Okay. Total going to be close to 11 sessions. Okay. Are we going to do Scala hands-on or Scala Spark REP through or through Scala SPT? We're going to do one project with the Scala SPT, and most of the project is going to be on the command line or using the Jupyter. So the way the class goes on is we will be working together in this class. So whatever I am doing, I would prefer that if you do it with me. Okay. So that's a general way we operate in the class. Yes, we'll be providing the recordings in the classes. All right. Is it different project executed for different course batches or same project? The project is generally same, but if the students are performing really well and showing commitment, we give the industry project to them. Okay. So a question from Kanji is that I've taken both Python and Java a couple of years ago, but I need a refresher. Which of the two do you recommend I review while taking the course? I will say that you don't need to. Okay, don't worry about this part. Okay, you don't need to because we are going to start with Scala in the next session, so you will learn by yourself. Okay, a question from Huey is that will you start a course on big data security? I'm not sure yet. We have not yet planned, but we might plan because there are quite a few people asking for that. A question is there any certification available for machine learning also? There is no third-party certification for machine learning yet. Okay, but we do provide this certificate from our side once you finish the project. Do we have local cluster my laptop during the course, or we have access to the lab? You will have access to the lab. Okay, and local cluster is up to you. We will help you with the guides. All right, I hope I have been able to answer your questions. I look forward to see you in the Spark session. From next session onwards, we will start learning Scala, and after that, we'll start learning Scala, and then we'll go into Spark basics, and we'll start writing and deploying. First one will be actually the RDD, and then we will go into this is what we're going to learn from here. Okay. All right. So I look forward to see you in the next session. Can we get support after the course? Of course, you get support after the course. Is it possible to just get recording of live session of machine learning that is scheduled today? If yes, every session is recorded automatically and is made available in your courses. If you go to my courses, you will find that. Okay, thank you. Kenji is saying that I noticed that your competitors are also using Cloudxlab will be competing with their users for shared space. Not really, not really. So, so we have that part abstracted, and in case there is a need of more resources, we generally put more machines. Okay, so nothing to worry on that front, that we generally take care. If you have questions after the session, how do we contact you? You can generally reach us at Cloudxlab. All right, so where is that slide? All right. So if you have questions, you can actually post on discuss.cloudxlab.com, or you can drop us an email at reachus@cloudxlab.com. All right. Thank you, everyone. I look forward to see you in the next session. Okay. We'll be sending you the recordings, and it'll be made available under my courses section. Thank you, Vidya. Thank you, everyone. Wonderful set of questions. I thoroughly enjoyed your questions. And thank you, everyone. Great to have you in the session. The last 18 minutes okay, we are running late by 18 minutes, but it's important to answer the questions. All right. Thank you, Michelle. Thank you, Naveen. Thank you, Siri. Thank you, Kenya. Kenji. Thank you, MN Admin. Thank you, Santosh. Thank you, Jayaprakash. Thank you, Shankar Krishna. Thank you. I look forward to see you. Bye-bye. Have a good day. Thank you, everyone. Wonderful set of questions. Great. Thank you, Mrinmoy, for the link. I'll take a look at that. Yes, Jayaprakash, you raised the hand. You have a question for me? Thank you, RL. Thank you, Jamie. Thank you, Anil. Thank you, Noor. Thank you, Shashadri. Thank you, Vivek. Thank you, Balaji. All right. Thank you for a wonderful set of questions. Thank you, Ardhavle. All right. Wonderful set of questions. I look forward to see you in the next session. Next session is going to be on Saturday at the same time. All right. You can enroll here for the next course. Bye-bye. Have a good day. You can enroll here on this link.